IMSAR is a small business that designs, develops, and manufactures high-performance airborne radar systems that can be small enough to operate from Group 1 through 3 UAS, but also have a high enough performance to operate from Group 4 and 5 UAS or tactical manned aircraft. I'm Neil Bailey, IMSAR Director of Navy U.S. Marine Corps Programs, and I would like to tell you about capabilities that we are currently developing through a SBIR Phase 2 contract with the U.S. Navy. Because our radar systems operate from an unmanned aircraft, the ability to perform missions autonomously without an operator in the loop is very important. IMSAR is currently performing work on a SBIR Phase 2 contract with the Navy to develop a radar system that can autonomously search for, detect, and classify maritime targets from a small, low-observable, unmanned airborne platform and communicate that information back to a Navy vessel. Once developed, this capability will increase the usability and mission effectiveness of small UAS platforms by allowing them to locate and identify specific targets in all weather and transmit valuable ISR data to a remote operator. This capability will benefit not only the U.S. Navy, but also other defense and non-defense users by providing a low-swap radar sensor capable of autonomously classifying targets. For our Navy SBIR, we are leveraging the components of our existing commercial radars to develop a low-swap sensor capable of performing autonomous, all-weather anti-surface search from a low-observable Group 2 UAS. For nearly 20 years, IMSAR has been developing high-performance multimode radar systems capable of performing in all-weather, day or night, and in other low-visibility situations, such as fog, smoke, and dust. IMSAR is a small business located in Springville, Utah. At our facility, we have both engineering and manufacturing capabilities to design, develop, manufacture, test, and operate airborne radar systems. Our engineering facility has the equipment and personnel to quickly design, develop, manufacture, and test our radar systems on our own airborne platforms. Our engineering and software teams consist of nearly 50 engineers with expertise in disciplines including radio frequency, algorithms, hardware, mechanical design, and user interface design. Directly across the hall from our engineering department is our manufacturing facility that includes state-of-the-art manufacturing equipment to produce the major components of our radar systems in-house. The close proximity of our engineering and manufacturing departments allows for quick reaction to customer needs, rapid prototyping, and troubleshooting. IMSAR also has the personnel and assets in-house to test and operate our radar systems, including flight testing assets and personnel with military, radar operation, and imagery analysis experience. IMSAR's manned aircraft are operated from an airport that is a short 5-minute drive from IMSAR's engineering and manufacturing facility. Using these resources, IMSAR has produced radar systems with industry-leading reliability that have proven their value in combat and multiple deployments. For example, our ShadowStar system was fielded in Afghanistan for almost 5 years to perform counter-IED route clearance missions. IMSAR's radar system is integrated on the RQ-21 Blackjack and has been designated by the U.S. Marine Corps as the ANDPY-2 sensor and is preparing for deployments with NSW and on U.S. Navy vessels. For our Navy SBIR, IMSAR proposed to address the Navy's challenge for a sensor payload capable of operating from Group 2 UAS to provide autonomous, all-weather, anti-surface search capabilities. Specifically, the Navy was searching for a sensor to perform all-weather search, locate and identify targets of interest, and transmit that information to a remote operator. IMSAR is working to address these needs. IMSAR's solution leverages our TRL-9 radar components and TRL-9 maritime surface search modes. Using these components and modes, IMSAR's radar systems are already able to perform wide-area maritime searches to detect potential targets of interest. Partnering with Arete Associates, IMSAR is able to use our maritime imaging modes and Arete's advanced classification algorithms to classify the detected targets. The information can then be transmitted back to a remote operator using IMSAR's advanced radar antennas as a common aperture for also performing directed communications. IMSAR will then integrate these capabilities with an autonomy engine to perform modes and functions with the ability to command the UAS platform autonomously. IMSAR is developing an all-weather radar system for the Navy that will operate from a Group 2 UAS and autonomously search for, locate, and identify surface ships and transmit that information back to a remote operator. Because IMSAR's radar systems are modular and scalable, This autonomous detection and identification capability can be integrated into a variety of unmanned and manned platforms. This ability to integrate on a variety of platforms will also allow IMSAR to provide this autonomous classification of targets to other departments and services that have expressed interest in this capability, including U.S. Army, U.S. Air Force, U.S. Marine Corps, and the Department of Homeland Security and state agencies. IMSAR's radar systems are currently deployed for multiple domestic and international customers to perform multiple missions. In their standard configuration, the radar systems are capable of performing variable resolution imaging, detecting changes, detecting and tracking moving targets, and performing maritime surface search for surface vessels. Our radars are also capable of performing high-range resolution and inverse SAR imaging of maritime targets. IMSAR's radars that are capable of performing these modes come in standard configurations ranging in weight from 7.5 pounds to 24 pounds. With custom configurations, the weight of our radar systems can be even lower. By the end of this effort, IMSAR will have added a machine learning classification processor and autonomy engine to the capabilities of our radar system. This system can then be launched on a Group 2 UAS to an area of interest and automatically perform a wide area search, automatically switch modes to image potential targets of interest, automatically send those images through the machine learning classifier, and automatically send back location and classification information to the remote operator on the host vessel. The goal of our current Phase 2 SBIR effort is to integrate our radar data with the Maritime Target Classifier, integrate the Maritime Target Classifier and autonomy algorithms on board the radar system, and demonstrate the onboard autonomy and classification capabilities on a surrogate unmanned platform. IMSAR is on track to complete the entire effort by February 2024. After successfully completing the Phase 2 SBIR effort in February 2024, IMSAR will have a prototype radar system integrated with a machine learning classifier and an autonomy engine ready for testing with potential customers. IMSAR's radar systems offer several key features and benefits. For example, IMSAR's radars have extremely low size, weight, and power characteristics, which allows them to operate effectively from UAS as small as Group 1. IMSAR's radars operate effectively in all weather, day and night, and even in low visibility conditions such as those caused by fog, smoke, and dust. IMSAR's radars are multi-mode and offer capabilities such as anti-surface search and target identification and classification. When integrated with an autonomy engine, this allows the radars to autonomously provide key intelligence in land, maritime, and littoral environments. To report target location back to a remote sensor, IMSAR's radars can integrate with existing data links or provide directed communications using the radar's existing aperture. IMSAR's radars have low maintenance costs because they are designed to achieve high reliability. The radars have demonstrated a mean time between failure up to 2,000 operational hours. IMSAR's radars have low procurement costs when compared to other radars with similar capabilities because IMSAR uses the same core components with all of our radar systems. Because they are modular and scalable, IMSAR's radar systems can provide an enterprise-wide solution for platforms ranging from Group 1 UAS all the way to Group 5 UAS and manned platforms. By the end of the Phase 2 SBIR effort, IMSAR will have demonstrated the autonomous detect, identify, locate, and report CONUP on a surrogate UAS platform developed by ONR. To initially transition the capability to operational use, IMSAR will work with the Navy Innovative Naval Prototype Full Spectrum Undersea Warfare Program to integrate the capability onto a government-selected medium to large diameter UAS platform. At the same time that IMSAR is transitioning with the Navy, IMSAR will be working to transition the capability on other platforms for the Department of Defense customers. IMSAR has integrated or is currently working to integrate the capability on several UAS platforms within the DoD UAS program office portfolio. In addition to providing these detect, identify, locate, and report capabilities to the U.S. Navy, IMSAR is excited to bring these capabilities to other customers both inside and outside of the U.S. Department of Defense on a variety of unmanned and manned aircraft. IMSAR is currently working with the multiple customers that will benefit from these capabilities once they are developed. These customers include Nordic Unmanned in Norway, who is currently performing a maritime surveillance mission in the European Maritime Safety Agency using Textron Systems Aerosonde UAS platform. Other government agencies who are currently performing counter-narcotics operations from manned platforms, U.S. Marine Corps, who is currently performing intelligence, surveillance, and reconnaissance missions using the RQ-21A Blackjack UAS platform, and Army Futures Command, who is currently developing capabilities for their air-launched effects platforms. By continuously innovating our systems, IMSAR is making our radars to be more adaptable to emerging and future threats. IMSAR understands the importance of interoperability. We have designed our radar systems to be platform agnostic, meaning our hardware is interoperable with multiple aircraft, manned and unmanned. We have also designed our software with standard inputs and outputs so that it is interoperable with the multiple sensors and mission systems. In addition to being interoperable with a wide variety of platforms, sensors, and mission systems, our hardware is also designed to be modular and scalable. Our different commercial radar configurations share common components and software. This allows our radar systems to be scaled to different airborne platforms and allows us to customize deep integrations for specific platforms. Sharing common components and software also allows development on one of our systems to be applied across all of our systems, which both increases the capability of all of our systems and decreases the development time and cost. IMSAR has also developed a radar control API and data products API that simplifies the integration of our radar software and data with other mission systems. With both domestic and international defense and commercial customers, we have designed radars for different platforms and performance requirements with radar systems capable of supporting a wide range of applications. IMSAR is democratizing radar by making them more affordable, available, and usable than ever before. Come and see how IMSAR is democratizing radar. Contact us to discuss how radar can meet your needs. Also visit imsar.com for more information.